Hello everyone. In this video, I want to show you something really cool that I just did tonight with ChatGPT. And I did it to help one of my capstone teams with the project they have, which is about autonomous 3D printers. So here, what I did was, let's say you go to Prusa Slicer, right? And then you slice this file, right? So you set up all of the infills and everything, and then you say slice it. And when it does, you're going to get something like this, correct? So here you can see that it shows the part when it's being printed. It shows the shells, it shows the infill, which I set at 20% and everything, correct? And then this is what it is. Now, if you want to see the animation of this toolpath, you cannot see it here. You can move, of course, this slider up and down, but this only goes layer by layer. So you see my layer height is 0.2, so it jumps from Z of 1 to 1.2 to 1.4, and it doesn't really show how the toolpath is moving. And this, all you can see here is assuming this one is given to you. Okay, you have this slicer and everything. Sometimes you don't even have this slicer or the CAD file. All you have is a G-code. So the software generated some G-code. Now this part of it, ignore it. But if you go down, this is what you have. This is all you have. So they gave you a G-code, and now you want to know how this G-code would really print the part. So you want to see something like this, correct? Where basically you can see different layers here, and you can see that red spot here is the toolpath. So as it goes through the part and creates all of the motions, and it makes the part layer by layer, this is basically what you want to be able to see. You want to animate the toolpath yourself. Okay, so can you do that? And this is done in MATLAB. So it has lots of applications, and here I don't want to necessarily talk about all of the applications of it, but can you get a G-code, a text file like this, and then interpret it in MATLAB and then animate the toolpath like this? Because once you can animate the toolpath, there are lots of other things that you can do. So here is, since I didn't want to write the code line by line myself, I tried to use ChatGPT, and here, look, I started, and first I make sure that it can do it. Say, hey, if I give you G-code from a 3D printer slicer software, can you write a code to plot the toolpath? So first I ask for the plot, and it says, yes, I can. Just give me the code. And it says I need to only focus on the lines that have G in them, G0 or G1, which shows the toolpath. That's all I need to care about, not the other things, right? So there is F line that shows feed rate. There is E that shows the amount of extrusion, right? If you go, we can see there are E's. And in a 3D printer, since it goes Z layer in one Z height, it goes all X and Y's, then goes to the next Z. If you can look here, at each Z layer, all it does is to change X and Y, and then it shows some extrusion amount, okay? And then when you go from one Z to the next, all it changes is the value of Z. So if you go down the code, you can see that basically it keeps one Z constant, and it does everything, and it then, look here, so it has a bunch of other parameters, right, for like fan, for heat, for motors, for all of those. But if all you care about is the animation of the toolpath, you don't need to care about lots of these other lines. All you care about is Z. Now let me, X and Y, and of course knowing what Z was. So you see here we go down the line, and then look here, you see there is wipe start, all of those you can easily wipe end. Now look here, this is for height of 0.2, and it does everything for height of 0.2. And then when you go down, then you see after layer change, then it goes to 0.4, and you see now you're at Z of 0.4, and it does everything for 0.4. Then once this is done, it jumps to Z of 0.6, and it keeps basically repeating, right? So it just does all of the motion for one Z layer. That's why we call it 2.5 axis. So this is all you need to know. Read these G lines, X, Y, see what Z value you had, and keep that. And one other thing that you have to pay attention to are these E's. Now, if there is a positive extrusion after E, that is where your filament is being extruded, and you should show that in the animation. But sometimes there is a negative E. What is that? That is when your hot end is moving from one point to another, and in between, you don't want to place down any plastic. It's just a fast motion going from one point to another to start maybe the next layer or anything. And here you're retracting the filament. Okay, so this is the part that you retract the filament, and you should not really animate those. If you do, and I'll show you, when you do that, then not only you're going to see all of this beautiful part, you're going to see, for instance, when this layer ends and it wants to go to the next layer, it jumps from this side to this side, and you're going to see a bunch of kind of cross filaments that are going all over this, and it kind of ruins your animation. The reason is when it goes from this side to this and it wants to start the next layer, it retracts the plastic, the filament between them, and you should not animate that. So you should exclude negative E lines from your basically G code, okay? And I did not initially do that, but after I looked at the animation, I found out. So here I continued with ChatGPT, and I gave it first a small portion of the code, and deliberately I gave it these lines that have M and everything in it. I just wanted to know if it really excludes them or not. And it did. It did not care about any of them. It jumped directly to here. So I just get a snippet of that entire big G code and gave it to it. So just a small portion, and say, hey, do it. It did. When I did this, it literally plotted it for me. The other thing it also did, it also plotted the portions that they are non-printing parts, okay? And I did not want that. So like when you start in the beginning, let me show you, when you start in the beginning, your toolpath, actually your tool is here. So it jumps from here and then goes there. This is in the middle of the tray, right? So your hot end is on this corner, so it comes here and then it jumps there. So first it lays a little bit plastic to purge the nozzle, then it jumps here. So it shows all of those as well, and I didn't want that, and so I asked it to skip all of those, right? So when it did this, the next time I said, make sure that this time I want animation, I don't want to plot, and skip the parts that are non-printing moves. And it did that, okay? And then I went to give it better things. So I said that not only that, make sure you show the XYZ location of the hot end as the title. That is where it added this portion for me. So you see, as it's going, it updates the XYZ. So your plot is actually showing the tool position. And I improved on it several rounds. And finally, this is the part that I asked it. You see, I said, do you know what number is in front of the E? And it says, yes, that's the extrusion. And then I said, so if it's negative, it means that it's retracting, huh? It said, yes, exactly, right? And then I said, okay, can you get rid of those lines for me? So sure, I can. And then it tried to get rid of the lines, okay? And you see that the way it is doing it is basically using the command read line. So it lines the G code, the text, line by line, starts all of the XYZ and the extrusions as empty, and then read lines line by line. And look here, it has this function start with. It says if the line that you're reading from the G code start with G1, then that is a motion. Go ahead and read that. Extract between the line and X. And this, and this, and this, and this. So it says, after this and the next empty spot, the blank spot, read whatever it is, that is going to be the X value. So what does that mean? It means go to this line, whatever is after X and between this blank spot here. Read that value, so it's going to be this, and assign it to X. Then whatever between Y and the blank, read it as Y. Whatever is after E, read it as E. Okay, so you see, this is how, if you look here, this is how it read those XYZs initially. Okay, and then Z does not really work properly here. Why? Because if you look at the lines, they don't have Z in them. As I said, Z is assigned one time, right? Z is assigned one time here, and after that, there is no Z in each line. So if you do it, it's gonna read a bunch of nans, or basically empty things. So it has to fix for that. It has to understand that only it assigns Z in one part, assign that Z to all of the lines below it, or above it, correct? And then what? Fills for all X's and Y's. So that's why later it had to rearrange a bunch of things here and check whether the Z that it reads is empty or not, and then checks whether the E values are all positive, so it keeps them. If they are negative, gets rid of them. Okay, so you see here, this is the final code, and I had to go several times. It gave several rounds of error, and I showed him showed the ChatGPT all of the errors that were generated by this code of it, like when it got nans and when it got another error. So it kept fixing, and ultimately, when it fixed all of that, finally, I said, okay, X's and Y's are good. You see, Z's are nan. It fixed for the Z's. And finally, okay, I said, now I want it to gradually create the curve and not show the whole toolpath all in the beginning. I want it to gradually increase the toolpath, like what you can see here, but instead of going an entire Z layer, when you move this slider, I want it to go all the points as well on that layer. And that's where it gave me this beautiful animation. Okay, and if you want, you can probably add some more stuff, time or anything as well. But let me run it again so you can see it from the beginning, right? And you can see how beautiful this animation is. You see, first it does the skirt. You see, it did that. And then here it is doing the shells. You can even see the infills here, right? This is the part I really like. Okay. These areas that are not shell, and then you see that the Z is at the bottom layer here, and then as it moves on, you're gonna see that this Z is gonna increase, and I can change the speed of animation and everything. So clearly you see that now Z went up to 0.6, so now you're in the second layer, and you can also see it from the side view and see that the first layer is set. Right, second layer is also set. This is the third layer, so you're at 0.6. You see here, if you zoom in, you clearly see there are 3 layers already made. Okay, so that is really beautiful, right? That is what I love about this animation, and it can help you understand G-code better, and you can even show that line if you want. Like when it goes from one point to another, you can even show that line. Hey, whatever line that you read, G something, GX something, Y something, extrusion something, and show that line as well here. So you can do anything you want with it. And this is really, really powerful. And all I did was to properly give prompts to ChatGPT to finally give me this final code here. Okay? So hopefully this video is useful to you, and I'm gonna, by the way, share this M file under video description. So if you have any G-code, all you need is to provide the name of that G-code as a text file here, convert it to a text file, and have it here, and this guy is gonna go through it, read it, and you can animate your entire G-code. So hopefully this video was useful to you, and I'll see you in the next video. Thanks.